I guess before we get to the question, let's talk about this. Because the scheduling was all messed up today because we had a delay, right? So you're not coming to class at the normal time. I pushed back today's assignment. It was due at the beginning of class until this evening at midnight. Okay, so all you gotta do is make sure you finish it by midnight. I gave 2 similar exercises on that in case there's some questions on that maybe you rushed through and didn't spend a whole lot of time on because you're trying to meet the original deadline. This is the only time that I will do that. Okay, from now on, if there are delays or cancellations, the due date that was assigned in class is still the due date. Okay, even if we're not going to be in class until what time? Does that make sense? So normally you guys don't start this class until 1:34, right? Okay. Right now it's 2:15. So if you would have waited till 2:10 when class started or something like that, you're already like a half hour late on that due date. All right. So just make sure that when we're delayed, when we're canceled, due dates are firm. The reason I do that is because I want you guys to understand that when you're outside of the high school experience and there's a due date for something, maybe I'm in a job and I've got to get a task done for my employer, and I missed that task, and there's probably a lot of financial burden that I just created my employer. And he's probably not going to like that, and they're probably going to get rid of me. Does that make sense? Yeah, so once you get exposed to that type of thing where due dates are important, if I go through a college course and they give me the syllabus, and in that syllabus it states all the due dates for all the assignments throughout the entire course, and I don't pay attention to that, and I start missing due dates, I can't go to the professor and say, hey, I didn't know that was in the syllabus. Can I turn these in late? The answer is going to be no. Okay? So I want you guys to make sure that doesn't happen to you the first time. It'd be extremely detrimental to you in a college course or in the workforce or something like that. Okay? I want you to get used to due dates being due dates, deadlines being deadlines, and doing the things that are required to meet this. So you guys didn't know last night that we were going to be delayed today. You don't know what you don't know. So right now we might be delayed tomorrow. Who knows? Okay? But don't put yourself in a situation where you're always putting off homework or always putting off something as close to the deadline as possible, because that time might not be guaranteed to you. All right? It might get taken away with the schedule that we had or something like that. All right? So, or maybe you're saying, I'm going to do it during Wildcat time. Do we have Wildcat time today? No. Okay? So make sure that you're kind of paying attention to that kind of stuff, because the next time we're delayed, I'm not going to go and change due dates and that type of stuff. One, because it's paying the butt, but two, I want you guys to learn the importance of those due dates. When we look at this question here and talk about the clock, a couple of reasons I want to talk about it is, one, you're going to see it on probably the test for this chapter, but two, in about 2 years, when some of you take me for trigonometry, we addressed this same question in that class, but we make it a little bit more difficult. I'll show you when we're done with this how we make that a little bit more difficult. But how many numbers are there? How many numerals are there on the clock? 12, right? So we're at 12, we got 3, we got 6, 9. Just trying to evenly space these. All right. And you guys know that within 2 o'clock to 3 o'clock, how many minutes are there? 60. Between 3 o'clock and 4 o'clock, how many minutes are there? 60. Between 7 o'clock and 8 o'clock, how many minutes are there? 60. So as we go around any 2 consecutive hours, there should be 60 minutes between each of them, right? And that tells me that there should be the same degree between both, because that hour hand has to move the same as if it was going from 3 to 4 as it would from 10 to 11. Does that kind of make sense, everybody? So what we do here, we'll do this way. How many degrees are, if this is my hour hand, if that's my hour hand, that's my minute hand, how many degrees are there between those two hands right now? How many degrees is that right there? 180. How many degrees is that? 180. So if my hour hand starts at 12, and then it works all the way around and gets back up to 12, how many degrees does it trace out when it does that? 360. So that's the key thing here that we need to understand. In a circle, there's 360 degrees. And you just told me that there's 12 numbers on here, and they're evenly spaced. So if I did this, that's terrible. If I did that, how many slices do we have there? Should be 12, right? Okay. And they should all total 360. And you told me there's 60 minutes between each hour, so we should be able to say that all of these slices have to be the same angle here, right? So can I take 360 divided by 12 and get the fact that one of those slices is a 30-degree angle? And any one I choose is 30 degrees. So let's say, that one right there, 30 degrees. So here's the question. It says if it's 9 o'clock, your hour hand is there, your minute hand is there, you have that 30 degrees, you have that 30 degrees, and you have that 30 degrees. And the angle addition postula tells you then what is that angle between those two hour hands, or the hour hand and the minute hand? Be 90 degrees, right? Okay. And if we change that question, if I say, okay, now what if it's 8 o'clock? Well, if it's 8 o'clock, I just incorporate one more 30-degree angle, so now it'd be 120 degrees, correct? Okay. So you saw some of those. Some people right off the bat got like a 6 o'clock answer or question, and it would have been 180 degrees, and then they go to the next one, and maybe they got 9 o'clock, and they can obviously see, well, that's 90 degrees. If you were a person that didn't get something like 8 o'clock or 7 o'clock or 5 o'clock, I think seeing this is important to realize that each one of those little increments is 30 degrees, okay? So we can change that a little bit, guys. We can make it a little bit more difficult by saying, okay, what if it's not, let's say, 5 o'clock, okay? Because 5 o'clock would be my hour hand there, or sorry, my minute hand there, my hour hand there. So now we're breaking it up into, what, 1, 2, 3, 4, 5. So it'd be 150 degrees there, right? Okay. But what if I said it's 5:30? It's 5:30. Think about where your hand and your hour hand would be, okay, and where your minute hand would be. If it's 5:30, isn't my minute hand right there at the 6? Okay. If it's 5:30, is my hour hand at 5? No, right? Because it's got to, as my minute hand starts to move around, the instant my minute hand moves to 12, this thing just slides over a little bit and becomes 6 o'clock, right? Okay. You never see the clock this go all the way to 12, and then that thing pass through that entire 30 degrees. So this hour hand is always moving as the minute hand is moving. But if it is 5:30, isn't the hour hand right there? Does that make sense? Splitting that 30 degrees. So if it's 5:30, how many degrees would that be right there? 15 degrees, okay? Last class, I think we did an example where it was 4:30, okay? So if it's 4:30, there's my, well, let's just say, we'll start off that way. We know that's wrong, okay? But that would be, two of those sections. That'd be 60 degrees, right? But we know that this hour hand should be moving halfway between 4 and 5. So my hour hand should really be there. How big is that little angle right there? That's the 15 you just told me, right? And then how big is that one? 30. So how big is the angle between the hour hand and the minute hand there? 45. Okay? So how do we make this more difficult? In trigonometry later on, we ask, okay, what is the span, or what is the angle between the minute hand and the hour hand when it's 4:17 or when it's 4:11 or something like that? We make those minutes a lot more difficult to deal with than 30 or 0 or 60, I guess. Does that kind of make sense, everybody? Okay. But if you understand that now, that the clock is broken up into those 30-degree intervals, it will make things a little bit easier down the road. So I think those two questions, 8 and 9, were structured that way. There's a couple of things that I want to talk about. Not so much maybe doing the problems, maybe we'll set them up. But the way that they're structured. And they come down to something like this. Okay? Again, I'm hoping that we did enough examples in class, or that provides you enough resources where you can see enough examples to really get a good grasp of the angle addition postula. But all this one is saying is, if I look at that picture over there, if I look at that picture, I'm going to look at the smaller two angles. So angle DBC Okay? So that's this angle here, the small top angle. Right next to it is CBA. So I'm going to add those two together. And that should equal my total, right? And the total angle is DBA. So measure angle DBA. Now that I've got that, now that we've developed that pretty straightforward angle addition statement, now it's just plugging things in. And I want to talk about the way that the information is provided for us. They tell me very upfront and very forward, they tell me that the measure of angle DBC is the same thing as 5x plus 4, right? Okay? When somebody is very forward with what they're telling you, okay, very upfront with what they're telling you, they're being explicit, okay? That's what we refer to as, you guys listen to explicit music, don't you? Okay, and they use bad words in that, right? They're being upfront with you. They're not telling you or trying to hide their feelings or what they're thinking. They're telling you this is the exact way we feel about it, and it's usually probably not maybe the most appropriate way of doing it, okay? If we go and listen to some other music, maybe they share the same kind of thoughts and feelings, but they use their words to where you kind of think that that's what they're thinking, and that's what they mean, but you're not really sure. Is that going to make sense? When that happens, that's called implicit, okay? Let's say today was Thursday, and I tell you tomorrow we are having a quiz. I am being straight with you, I'm being upfront with you, I'm being very explicit with you, right? Well, let's say today was Thursday, and I say, guys, it's been a week and a half since we had a quiz. I like giving quizzes on Fridays, okay? It's not going to be a pop quiz, okay? But maybe if we have a quiz tomorrow, you know, it's probably because maybe it's Friday. What am I implying there? What am I telling you? Quiz tomorrow, right? I never came out and said straightforward, quiz tomorrow, but I hope I said enough stuff there that you say, okay, I see what he's doing there. I see that he's implying that I should probably prepare tonight. I should probably be ready for a quiz tomorrow. What they're telling me about this angle right here, they're being very explicit. They're telling me exactly what I know DBC needs to be written as. CBA, measure angle CBA, again, being very explicit. It's 5x minus 3. So I put that in. Okay? And the real information that I want to talk about and really talk about why we're talking about implicit and explicit kind of definitions here, is that they tell me my total explicitly. They tell me exactly what my total has to be. It has to be 71 degrees. Okay? So pretty much all the information in this problem is straight up pretty forward with you. It's very, very easy to recognize what those parts need to be. Okay? I want to draw a comparison to that question to, I think, question 18 maybe. Because now if I look at question 18, I'm going to write the same type of angle addition statement. I'm going to say measure of angle, was it RQS plus measure of angle SQT is equal to the measure of angle RQT. All right, and they're straightforward with me in regards to what RQS is. They're telling you RQS, that there has to be 11x plus 4. They say SQT has to be 8x plus 5. Okay? Do they come out and tell me, like the last example, that angle is this number? Nowhere else in the problem do they say, like the last one was 71. Nowhere does it say that, right? Okay? They hide that information. They hide what you have to put there in a vocabulary word. And that's the vocabulary word. Okay? And if I don't know that vocabulary word, I'm not going to be able to set up the right relationship. Does that make sense, everyone? And that's the importance a lot of times of our vocabulary words. So what did straight angle mean to us yesterday? Okay, so it's an angle that creates a line essentially, but it incorporates 180 degrees. Nowhere in the problem does it use the number 180. It's implied with the vocabulary word. Okay? And there's several times throughout this class, well, pretty much every section you're going to see this, where maybe a number like that is implied through a vocabulary word that leads you to another vocabulary word, that leads you to another vocabulary word, that then presents you the number that we need. So if I don't know my vocabulary words, I'm really going to struggle in being able to kind of follow the path of where the questions are trying to lead me. Okay. But once I set that up, then we can go ahead and solve that just like we solved the last one. Okay. They're implying values to you. They're hiding things. They'll always give you enough stuff. Okay. They'll always give you enough stuff. But you got to be able to read into it and recognize that. It's very similar to like last year. If I would have given you, Miss Coles would have given you like M is equal to 2/3, and your maybe your y-intercept is equal to, I don't know, 0,4. Could you write an equation for that? Could you go y equals mx plus b for that? Okay. Your b term in this case would be that 4. So you could say y equals 2/3 x plus 4. Okay. They gave you, they were pretty explicit in what your slope had to be, what that term right there had to be, and pretty explicit with what your b term had to be. Okay. You also saw equations last year where it said this line passes through the point 0,4 and also the point maybe let's see here. I'll just make one up. 2, 5. Okay. Find the equation of the line. In that, I didn't tell you what slope was, right? But it's hidden because you have a formula that you can use to determine slope, right? You can do y2 minus y1 over x2 minus x1, and that'll give you the slope that you need for your equation. And if I look at that 0,4, well, that's the same idea in the last question. That's the y-intercept. So now I know my b value. Does that kind of make sense, everybody? So you've seen situations where values or ideas or concepts are hidden, maybe in a formula or something like that, but you've got to be able to pull them out. All right? And that's something that we're going to focus a lot on in this class, because it becomes just common practice later on in other courses. Okay? If you don't learn that now, it's, like I said, it's going to be problematic later. That one, this is the same exact kind of situation. Okay? Nowhere, obviously, hopefully you guys recognize, I need to take this expression here, because that's the top part of this angle, and that bottom part of the angle, they're right next to each other. I should probably add those together, right? But what do I set them equal to? 90 degrees. Nowhere in the problem does it say these two things need to add up to 90, okay? But if I look right there, okay, that's the notation, that little square in the bottom, that's the notation to tell us that our angle is a 90-degree angle, okay? So again, in notation, it brings us to the fact that that's a right angle, and then the vocabulary of a right angle, the definition says, oh, it's an angle of 90 degrees. So you see we got a picture, it leads us to a vocabulary word, a vocabulary word leads us to a number, right? And now we can set up our equation the way we need to. Alright? So it's going to be things throughout the whole year that we have to be able to kind of play that game. Okay? So step by step, where does this information, this notation, vocabulary, where does it lead me next? And see if that leads me somewhere else. Okay? Until I can make a relationship, make an equation. I don't know if we talked about this in your guys' class yesterday. Hopefully it kind of follows suit with how we talked about congruent segments. But if I have two angles that are congruent, there's kind of two types of notation that we can use, or that you will see being used a lot of times. And if there's multiple ways of notation being described, I'm going to show you all of them. I'm going to try to use them all, because I don't know how the author on the end of course exam is going to use their notation. Does that kind of make sense? So if there's 3 or 4 different ways to use notation to show congruency, I'm going to use all of those different ways, so that's not, May 1st and it's the first time you've ever seen it, and that first time you've ever seen that notation is on that test. Okay, so it might be kind of a pain in the butt at first, but I think it'll pay off for you later. That means that those two angles are congruent. Okay, it means they're cut and paste images of one another. If I wanted to say that somewhere else there are other angles that I've already got one mark in, and I don't want to say that these two angles are congruent to those other ones that have one mark in them, you can do this. I think maybe you see that in one of the first questions on this assignment. So everything that has two arcs in it are now relatable to one another. We compare them when I said those two are congruent. And I can go out as far as I need to. And I think that process is a little ugly, but it is a technique. I like this because it's consistent with what we do with segments. If I want to say that these two angles are congruent, I do that. Okay, the arcs in those marks. Because that's a little bit cleaner when I want to start using more marks. Okay, or maybe I need to use 3. I think that's a little bit cleaner than putting 3 separate arcs in the angles. Is that all right with everybody? So that notation means that those 2 shapes are congruent. Now, if I look at those 2 shapes, it says angle AOB is congruent to angle COD. That's the 2 angles we've marked here. So that tells me that measure of angle AOB should equal the measure of angle COD, right? I should be able to pull that information. Measure of angle AOB is 5x minus 8. Measure of angle COD is 3x plus 8. Okay, a little bit of algebra here. Should give me x to be 8. Okay, I'll let you guys do that algebra on your own. But if x is 8, is that x referring to that x right there? Yep. Is it referring to that x right there? Is it referring to that x right there? Yes. And even though I did not use that expression, in solving the equation and setting up a relationship, that expression is true, and it's using the same x that I've used in my equation. Okay? It's come from the same picture. So if x is 8 for angle AOB, it's 8 for angle BOC as well. So the next question I'm going to ask you, what is the measure of angle BOC? Even though I didn't use that expression to solve my equation to determine my x value, I can still plug that x in here, okay, and get 8 times 5 is 40 plus 12 is 52, right? And get that 52 degrees for a measure of angle BOC. Even though I didn't use BOC to work through the problem, okay? If they wanted to mean something different, if they didn't want that BOC to have that x being the same, they would have called it y. Does that make sense to everybody? All right, and then x and y obviously different variables, so they represent different numerical values. I think, guys, those are the ones that, for the most part, people struggle with. There's one here, this one. Is my friend right? Are those 2 angles up there, JKL and LKM, are they congruent? No, okay? And really, when we say that our classmate is not correct because they said that they are congruent, but we still may not even know if that's true or not. They could be 100% congruent. They could be 100% incongruent or different. We just don't have enough information. Does that make sense, everyone? Okay. We would want to put markings in those angles. Okay. Well, maybe we put both right angles up there so that they are congruent. Maybe we put those arcs in there with the slash in to show that they are congruent. But my classmates' argument that they are indeed congruent, they would be wrong. Okay. We just don't know. And what I want to kind of show you, and we'll be done, but is this here. That angle right there, if I look at that, it looks like what type of angle? It looks like a right angle, okay? Now, if I put that measurement back in there, GeoGebra does a good job of measuring angles. It's using trigonometry. It's very accurate, and it's saying that angle is 89.998. Is that a right angle? No. By definition, that's an acute angle. But your eyes can't tell the difference, right? So when you're looking at something in a textbook, in Math Excel, and they don't tell you that this is a right angle, or they don't tell you that these lines are perpendicular, or something like that, even though it would make things really convenient, okay? Things are really nice if that's a right angle. We can't make that argument, all right? And if we can't say it's a right angle, doesn't mean it's not a right angle. Does that make sense to everybody? Okay? We just don't know, all right? And that's what we're kind of leaving it as. We cannot make a conclusion yet about the type of that angle. So those are little things that, in 12 years of teaching, I've found that if we can explain that type of stuff and understand that even though it looks like we want it to be that, but we can't make the conclusion, if we can justify that and convince ourselves of that stuff right now, again, it's going to make the end of the year much easier. All right. At some point, every year, somebody gets into trouble in regards to their homework or tests or quizzes because they make assumptions. Okay? Do not make assumptions. In this class, everything's got to be kind of cut and dry. Okay? You can only assume what they're telling you. Okay? So it's really not an assumption. You got to take what they're telling you and only use it in the way that they're telling you. All right? And if we can do that, it's going to be a good year. All right? If we make a lot of assumptions, we're going to get ourselves in trouble and get really confused. Is that all right?